Hello. So this time we still are on section 6.2, only part 2, which is the volume of rotation and the washer method. Okay. So we already explained the concept, and now for case 1, so let's just go back here quickly. You can see we discussed already the concept. So this was the concept of a case 1 of the volume of rotation and the washer method. So we went through this. So now we're going to do an example on case 1. And let's start with the example. So the example is here. Find the volume of rotation by the washer method. So they describe the region to be bounded by y equals 1 minus 1 over x, y equals 0, x equals 1, and x equals 3. And the rotation is about the line y equals negative 1. So for the solution, the first step to the solution is to sketch the region. So when you sketch y equals 1 over x, you get this curve. So y equals 1 over x equals 0, in this case, represents the x-axis, which is this, and x equals 1 is this vertical line at x equals 1, x equals 3 is this vertical line at x equals 3. So the data give us this region R. Okay, this region that you see here, shaded region. So then we go to the rotation. It says you're going to revolve it about the horizontal line y equals negative 1. So this is y equals 0. We go to negative 1 here, and then we draw our y equals negative 1. As you can see, this problem needs the washer method, because you can see you have the space, empty space between the line of rotation and the region. So you know clearly this problem cannot be solved using the disk method. So we mark the rotation by those curved arrows, and as you can see, the region is bounded by x equals 1 and x equals 3. So this will be our limit of integration. So a is 1, b is 3. So then we draw our cross-section line, okay, inside from one end of the region to the other end of the region, and it's going to be vertical. So because that's the slicing, so if you project, so this cross-section line is actually touching the x-axis at x. So we know everything must be expressed in terms of x. Now, the bottom end of the cross-section line to the line of rotation will give us the inner radius, because this is the inner circle. So the inner radius is the distance between this point and that point. This point is called y equals 0, and the center here is called y equals negative 1. So the distance between 0 and negative 1 is 1, because the distance should be positive, right? You're going to take 0 minus negative 1. So that gives us the inner radius. So again, I'm trying to explain it here. This is the inner circle, and this is where the x-axis is. The equation, the x-axis is y equals 0, and the center is the line of rotation, which is y equals negative 1. The distance between 0 and negative 1 is 1. How do you get it? You take 0 minus negative 1. which give you positive 1. So our inner radius is 1. Now, the outer radius, you get it by this end, the top end point of the cross-section line to the line of rotation, because that's the radius of the bigger circle. So it goes from here to here. So what is it? So the top point here is the function itself, 1 over x. And the center is at y equals -1. So the outer radius is going to be 1 over x minus -1, which gives you 1 over x plus 1. Okay. So that gives us the outer radius. So now that we got the inner radius and the outer radius, we can just follow those routines. So all of those were part of step 1. So now we go to step 2. We write down the inner radius. Step 3, we write down the outer radius. Step 4, we find the inner area. Okay, the area of the inner circle. Call that the inner area, which is pi times the inner radius squared. So inner radius is 1, so we get only pi. The outer area is going to be pi times the outer radius squared. The outer radius is 1 over x plus 1. So this quantity will be squared. When you expand it, you get 1 over x squared plus 2 over x and then plus 1. Step 6, that's when we find the area of the washer. We know the area of the washer is the outer area minus the inner area. The outer area is given by pi times quantity 1 over x squared plus 2x plus 1 minus the inner area is just pi. And when we distribute, we open, because we can factor out the pi. So you get pi times quantity, then you copy this, and then here when you factor out pi, you're going to be left with minus 1. So plus 1 minus 1 goes, give you 0. So we end up with the area of the washer to be pi times quantity 1 over x squared plus 2 over x. Step 7, that's when you're going to integrate the area of the washer in order to get the volume of rotation. So I already told you about A and B, which is 1, 2, 3, and then we're going to integrate for 1, 2, 3. We're going to integrate pi times quantity 1 over x squared plus 2 over x dx. So with 1 over x squared, we cannot integrate it like that. We have to express it as x raised to -2. And then we will pi is a constant. We're going to factor out pi and then integrate x raised to -2 just by adding 1 to -2 and then divide by -2 plus 1. Plus 2 is a number. Then you integrate 1 over x, which is this natural log of absolute value of x. And when you get this expression, you will have to evaluate it at 1 and 3. So you always start with the upper limit. So you from here, when you, so -1 plus -2 plus 1 is -1, and -2 plus 1 is -1. So you have -1, but x raised to -1 can be written as 1 over x. So this basically will give us -1 over x. Now, when you plug in 3 into this expression for x, you get -1 over 3 plus 2 times ln of 3 minus quantity. Then you plug in 1 for x into this expression to get -1 over 1 plus 2 times ln of 1. ln of 1 is a 0. So here you're going to get -1 divided by 1 is -1. Because of this negative and minus, it makes it +1. And here we just get the same thing. So we combine like terms, so -1/3 plus 1 give us 2/3, and then plus 2 ln of 3. Well, you can stop here, but you can use the property. The way I did here, I use the property of natural log. So 2 times ln of 3. This 2 is the exponent of 3. So you can write this as ln of 3 squared, which is now ln of 9. Now we remove the absolute value because we don't need it, because the 3 is positive, so you don't need the absolute value. Because the absolute value of a positive number is positive, that's the same number. And then you get V to be, the volume to be pi times quantity 2/3 plus ln of now. So that's that example. And our next video is, we'll do another example. Okay, so for this one, we're going to stop here. Thank you.